Hi, Oscar. So today is a very special day. It is the 30th of July 2020, and it is the launch day for the Mars Perseverance rover. It follows the Opportunity rover that launched around about a decade ago, and it's still on the planet Mars now, operating, taking samples, making measurements, and so on. But today is the turn of the Mars Perseverance rover, and you'll see a little countdown clock here in the corner of the screen, and that's because it's just about 10 minutes until launch of the rocket. So I just wanted to give you a little brief overview of the mission, and also a little something very special just for you as well. Obviously, this video is made for you when you're a bit older. You're only 3 years old now, but soon you'll be able to see this and enjoy it. So let's take a look first at the rover itself. So the rover is a six-wheeled roving machine. Essentially, it can go over, it's designed specifically to go over the rough terrain of the Martian landscape. It's got equipped on it so many different cameras that are used to detect right the way from optical all the way through to other parts of the electromagnetic spectrum. This arm on the front here that you can see is specially designed to extract samples from the Martian surface. And what's really cool about that is they're going to extract samples, leave them on the Martian surface, and then something like 10 years later, another rover will come back, pick up those samples, put it into a rocket, eject it from the Martian surface to a satellite orbiter, which will then return to Earth, and then we can get our first glimpses of real Martian regolith, or Earth, oh, not Earth, Martian soil. So yeah, okay, we're just 9.5 minutes to count down now. So this is what the rover looks like. When it launches today, it's going to launch from Earth with an acceleration of approximately 3 Gs, and eventually it will reach orbital velocity, and finally, after the second stage of the rocket launch vehicle, it will be able to escape Earth's gravitational field. It will take around about 6 months from now to get near to Mars, and it will land on the Martian surface on exactly 21st of February 2021. Now, there's a launch window that starts from today but goes right the way through, I think, until about 2 weeks from now. But regardless of when it launches within the next 2 weeks, it will definitely land on the Martian surface, all being well, on the 21st of February 2021. You can see the trajectory here. There's Earth in blue and Mars in orange, and the sun in the center. Now, when it goes to Mars, it will be completely autonomous. There'll be no controlling of the descent, because there's a 20-minute round-trip delay for any signals to leave from Earth to Mars. So we won't be able to control the vehicle, so it's completely autonomous. And it will use the so-called sky crane that I just want to show you now, actually, because it's really neat. Sky crane, Mars. It will be based on this idea where we have to get it up here. We're based on this idea. This is the once it's in orbit around Mars, it will start to descend down, remove its heat shield, and eventually fire up these rocket boosters, and then the Mars rover itself, which is on the bottom here, will slowly be descended down onto the Martian surface. So that's the rover itself. We've got the trajectory. Whereabouts on Mars is it going? Well, this is actually really fascinating because one of the main purposes of this mission is to try and find signs of life on Mars. So, as scientists, we believe very strongly that parts of the universe where we see water and oxygen are most likely to harbour life. And in the history of Mars, there was such a place, and it's in the so-called Jezero crater, where there was at one point liquid water, or so we believe. And the evidence we have for this, the Jezero crater, is just here. I'll show you this crater in the middle here. And the evidence we have for there being liquid water is if we zoom in here onto the crater, we can actually start to see the outlines of what looked like a historic delta or river mouth. And this is where the Mars rover will land, somewhere around here or thereabouts. And because it can move, it can go from one place to another, and it can go to this historical riverbed, take samples, and see whether it can find signs of life in terms of complex organic molecules, or who knows? I mean, we just don't know. So it's really, really exciting. So that's the Jezero crater that we'll land in on the 21st of February 2021. Mars is quite a fascinating place. It has a much lower gravitational field than Earth, so you feel a lot lighter on Mars. I think something around about a third of your weight here on Earth. It also has an atmosphere that's around about 1% of the Earth's atmosphere. So when there are like dust storms and things like that, it's obviously it's not great to have dust storms, but they don't affect the rover all that much because the atmosphere is just so thin. So I can see we're getting very close to the launch time. We're just 4 minutes out now. Let's just take a quick look at the launch pad here. This is the your first view of the launch vehicle. This is United Launch Alliance. What is it? The Delta Heavy, I think. And it's got 4 solid rocket boosters on the side, as well as a main engine, and there's a lower first stage and an upper second stage, and that will launch the Mars Perseverance rover on its way to Mars. Now, before we get to the launch, I just want to tell you something really special that I've done for you on this particular mission. So a couple of years ago now, the Mars team at NASA asked many people if they would like to have their name on the Mars rover. And of course, I naturally thought about you, Oscar, and decided that I would put your name on the Mars rover. And at the very front of the rover, we'll just go back to the rover just to take a little glimpse here. You can see a little circular round thing just on the front of the rover there, and this is where the names are stored on these 3 silicon chips just on the top of the rover there. And there are over 10 million names, and yours is one of them. And what's fascinating about it is that I actually have your boarding pass here that I signed you up for in 2018, a year after you were born. And I recently looked at it again, and it says now boarding. So on top of the launch vehicle is your little boarding pass here, and you, my son, are on the Mars rover, and you will be launched to Mars, and your name will land on the Martian soil and be forever there. How about that? Is that awesome or what? Wow. Okay, well, we're getting just to 1 minute before launch here, so let's move over to the audio for the launch and see what's happening
on this mission.
SCS count started.
1 minute 15.
Produce ECS
this
for
is
launch.
the most exciting part here.
1 minute 10.
Then bells locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right there. Public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So
Very exciting.
we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable
venting is
at
the
step
vent
three.
valves
Your
are locked
little
up to
your
put
name
flight pressure
is
into
on
the
there,
tanks.
Oscar.
And as we
You
just
are
heard, they're
launching
stable at step
on
3,
the
which means
Mars
the tanks are ready
Perseverance
to go.
Rover
And here
2020.
in about 5
And
seconds,
we
we
will
will hear the
be
team
ECS reduced for
on
launch.
the
Goodbye,
Mars
25
surface
Status check.
in February
Go, Atlas.
2021.
Go, Centaur. Go, Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Just making the go calls now from all the systems engineers to check whether the launch can go ahead, and it
8,
seems good.
7, 6, 5,
5.
4. Engine ignition. 2, 1, 0.
Oh, look at that.
Liftoff. As the
Fantastic.
countdown to Mars
Woo!
continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
There you go, Oscar.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good.
See the
Yeah,
velocity
Mach 1,
and the
Atlas
height
5
there in
now
the left
supersonic.
corner. It's already traveling faster than the speed of sound.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
Maximum dynamic pressure is the point at which there's the most load and forces on the vehicle. So they always call that out because it's the most sensitive time. Things can go wrong. It looks like we're passing through that now.
And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure
That's the
signatures
solid
look
rocket
good. Standing
boosters
by for
have now
SRB jettison
depleted.
shortly.
So they'll be jettisoned now. You'll see them fall away in a moment, hopefully. No, United Launch Alliance haven't absolutely. There they go. So they're the 4 solid rocket boosters.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time.
So the vehicle is completely autonomous. No one's controlling it. It's all controlled by the onboard systems navigation computer. Once it launches, it takes over entirely, including all abort sequences as well. Hopefully we won't have any.
And coming up
today.
on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
Wow, 6,000 miles per hour. Your name is traveling at 6,000 miles per hour, Oscar.
And the Centaur reaction control system is now pressurizing to flight levels.
That'll be for the upper stage Centaur system. At 200 kilometers.
And just past 3 minutes into flight, the
200
RD-180
miles
is now throttling to maintain a
altitude.
constant 2.5 G acceleration limit for payload bearing jettison. Engine response and vehicle acceleration look good.
Wow, look at that image of the Earth there. Amazing. It's leaving Earth and going to Mars. Those are the fairing
And we have
halves.
good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
Those will just fall back down to Earth now and burn up. They won't be recovered.
And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
This is good.
And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
The RL-10 is the second stage
Standing by
engine.
for MECO shortly.
MECO is main engine cutoff, and it happens at the same time as the first and second stage separation.
BECO is the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation.
There we go. What a view. Second stage
and we
fires
have
up.
good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we
from
have
the
MES
rocket.
1. RL-10 operating parameters look good.
You see the RL-10
Chamber
engine
pressures are stable.
gimbaling there. The gimbal, or the movement of the...
This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
Oh wow, so it's quite long. The RL-10 engine there, it's moving around just to control the direction. It's called vector thrusting.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust.
There's your name on the
cleared the
Mars
tower
Rover,
in
Oscar.
roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. It's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined, as Tori also said, courageous.
Okay, so I think we're just going to leave them there now. The second stage is going to fire for about 7 minutes, and it'll fire later on to get into the Mars-bound trajectory. And as I say, it'll take 6 months for the Mars rover to get to Mars, and we will cover the landing as well, although we won't be able to see it live because, as I said earlier, there's a 20-minute round trip delay for signals. But as soon as the footage comes to us, we will check it out and we'll do the landing together as well. That'll be really exciting. We'll get the first images back really quick as well. Well, within 20 minutes. Here. Yeah. You can actually see the payload on the very front there, that triangular thing or cone-shaped thing. That is the underside of that. The orange part of that is the heat shield that's going to face into the Martian atmosphere and make sure that the rover itself doesn't burn up. And inside there is both the Sky Crane and the Perseverance rover. So this booster is just trying to get the Mars rover up to speed so it can reach the planet. Eventually, it will also be jettisoned. You can see it's almost reaching maximum velocity now as well.
much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn.
As he's saying there, the launch is only really just one tiny part of the mission. Really, the nail-biting moment is going to come when we try to actually land on the Martian surface. Okay, so with that, Oscar, I'm going to leave you now, and I will speak to you tomorrow, actually. It's my birthday. Yeah, I'll speak to you soon. Bye.